Let's address the question regarding overload protection on transformer secondary conductors, specifically concerning single-phase transformers. The inquiry centers on the application of the rounding up rule for conductor sizing in relation to transformer secondary protection methods as outlined in the National Electrical Code, or NEC. The NEC section 240.4 B addresses devices rated 800 amps or less. It permits the next highest standard overcurrent device rating if 2. The ampacity of the conductors does not correspond with the standard ampere rating of a fuse or circuit breaker. The question further asks if the transformer ratio multiplied by the primary protection establishes an absolute threshold that the secondary conductor ampacity cannot exceed, essentially questioning the permissibility of rounding up the conductor size in this specific context. Based solely on the provided text, it's important to note that it doesn't explicitly mention the rounding up rule itself. Therefore, directly commenting on its application in this scenario using only the presented text is not possible. However, we can clarify the contents involved. NEC section 240.4 F specifically deals with transformer secondary conductors. It outlines a method where single-phase transformer secondary conductors can be protected by the primary overload protection device. This protection is valid if the primary overload device's value, after being adjusted by the transformer's voltage ratio, doesn't exceed the secondary conductor's ampacity. The calculation to determine the maximum allowable primary overcurrent protection is as follows. You multiply the secondary conductor ampacity by the secondary to primary transformer voltage ratio. The resulting value is the maximum primary protection allowed. Now, to answer your question directly, without information about what rounding up rule to which you are referring to, it's challenging. However, in general electrical design, you can sometimes go to the next standard size overcurrent device if the conductor ampacity does not exactly correspond to a standard fuse or breaker size, as outlined in NEC section 240.4 B. However, the specific case of transformer secondary conductors protected by the primary, the rule described in 240.4 F creates a limitation. The calculated value of transformer ratio times primary protection acts as an absolute maximum for the secondary conductor ampacity, meaning the maximum overload protection for the secondary conductors is determined by multiplying the transformer's secondary to primary voltage ratio by the primary overcurrent protection value. If this number is exceeded, the secondary conductors are no longer considered protected. In essence, the primary overcurrent device's protection extends to the secondary conductors through the transformer's turns ratio. It's a derived protection method. It's not simply about the conductor's inherent ampacity alone. It hinges on the coordination with the primary protection as mandated by NEC section 240.4 ALF. Therefore, while general conductor sizing might allow some rounding up under NEC section 240.4 B, the constraints imposed by 240.4 F on transformer secondaries must be carefully considered first. The calculation result from the transformer ratio and primary protection establishes a ceiling. Without having access to your drawings, calculations, and specific equipment being used, I am unable to say for sure what is happening in the field. It is recommended that you consult the local and national electric code, along with your electrical engineer, to be certain that the installation is performed correctly.